So we have looked at coming to a general solution for differential equations and how they are dependent or independent of each other. So in this video, we're gonna graph them and we're gonna see how the pattern looks and hence what we can see from the graphical solutions. Okay. So the first case that we are gonna look on is when the answers or when the solution looks as a nodal source or a nodal sink. So this is our first type of graph that we are going to have. Okay. And how we do this is, if we have, and the general solution or a common thing which we should remember is, if lambda is greater than 0, okay, we have to say that it goes outward or away from the origin, right? And if lambda is less than 0, it's going to come inward or towards the origin. So this is the basic thing. So with that, you can just think about it. Source means where it starts, right? So a nodal source would be something when it goes from the origin to infinity. That's how it is going to be. Okay, so using eigenvalues and eigenvectors, we are going to see how it's going to differ. Okay, so if we have eigenvectors, let's say my first eigenvector is v1 and my second eigenvector is v2. Okay, if v1 was, let's say, 1 1, it means that for every one unit increment in x, there's going to be 1 unit increment in y, and hence it touches the origin and it's going to hit this point also, and my line would be a 45-degree line. Okay, and for example, if my v2 was 1 2, it means that for every one increment in the x direction, there's going to be 2 increments in the y direction, and hence my line would look that way. Okay. You can take a minute to pause here and try drawing these lines so that you'll be clear. So I'm just going to make a small change. I'm going to do it as -1 and 1 and 1 and 2. So my 1 2 line would look somewhat like that. Now -1 1 would just be the mirror image of the 45-degree line. So it would be something like that. Right? Okay. So now I've drawn my eigenvectors with my solution. Now I'm saying that if my lambda 1 and lambda 2 are greater than 0, which means they're both positive, right? So it's going to go away from the origin, right? So I can just draw these things just so that I can kind of start visualizing how it looks. So in this case, I'm going to start from the origin, right? So let's say I come to a point on this region, okay? In this region. So I start off over here, but then it's going to fly off to the origin, right? So it'll go this way to the origin. And I can just continue plotting this one. And anything closer to this would just come this way. And if it's this way, it gets pulled towards this eigenvector. And also remember, it's pretty important to know to which eigenvector it gets pulled, but I'll just cover that in a second. Okay, and over here, it's going to go towards this vector, right? So it'll fly off in the other direction. So over here, there's going to be away, and over here, it's just going to go towards that vector. So this is approximately the curve And we call this as nodal source because it's going to start from the source and then it just goes away from it. So the origin acts as the source for us. Okay, so that's the first drawing. In the second case, we have when both lambda 1 and lambda 2 are less than 0, when they're both negative. So again, I'm going to draw my eigenvector first, eigenvectors, okay, and then, oh, they should all pass to the origin, okay, yeah. And I'm going to look at my eigenvalues. They're both negative, so they're both going to come inwards now. So it's going to be pulled towards one of them. So if I'm going to start with a point over here, so I'm just going to come towards this because that is pulling me downwards. So if this is more powerful than that, okay, it comes here, but when it comes closer, I need to go down, right? Because I can't go further because now this vector influences more. So I'll just come down that way. It should be more curvy, but hoping to get the point. So if I just continue that, and this is how it will come. Okay, so same way I can do it on the other side. And since they all go towards it, they all sink to the center, you know, the origin. So over here, we call this as the nodal sink. Okay. The main thing in nodal source and sink is you need to decide which vector influences it more. So when you have a solution, for example, e raised to the power minus 6t times one vector and e raised to the power, let's say, t times or minus t times another vector, right? Over here, both of them are negative. Both of my eigenvalues are negative. So if you just look at this vector, right, goes 6 times faster than this one. So this is what influences it more. So this tells you the major direction of the movement of the particle, and this is not that much empowering, right? So over here, although this one's going down, but it goes really fast in this direction, right? Yeah, so it goes really fast in that direction. So this one has more power. So this one comes more closer towards the center, but on the sides, it's going to come slower. So over here, it's just going to move straight, almost parallel to it. But when you see, when it comes near this vector, which is, let's say, e to the power minus 60, it just goes very fast to the center. So this is the basic idea. Okay, I'll continue the remaining type of graphs in the next video.